All right, in this video, let's go ahead and use ratio and rate tables to go ahead and solve and understand proportions and equivalent rates and ratios just a little bit better. So for questions 1 through 3, we're going to go ahead and complete these tables. Some of them are ratio tables, some are rate tables, okay? We're going to go ahead and make sure we also follow up with the any questions that we have to answer and write and solve a proportion as well, and then state whether each table actually represents a table of ratios or a table of rates, depending on the types of units that we have. So let's get right into it. For number 1, a wildlife conservancy maintains a ratio of 2 squirrels for every 8 birds. How many birds would there be if there were 15 squirrels? Okay, so we could jump right to 15, but we're going to also fill in a table here and make sure everything makes sense. The first thing I'm going to do here is see, okay, 2, if you double 2, that's 4. So if we double this 8 and maintain the same ratio here, this would have to be 16. You could also just say, you could do 2 times 4 is 8, 4 times 4 would also be 16. There's so many ways you can do this, or you can say this cross product's 32, so this cross product must also be 32. Hopefully this makes sense. Even if you look over here, 4 times 20 is 80, 5 times 16 is also 80. Okay, so lots of different ways you can do it. To get this box over here, I think a quick thing you could do is just double this 20. If you multiply it by 2, then just multiply this 5 by 2. That means this has to be 10. Another way you could do this, I'm thinking, is 8 times 5 would be 40. So 2 times 5 would also get you that blank over there. Okay, cross products here, this is 200 if you multiply, this is also 200 if you multiply. Finally, for this box over here, I think the most useful box you could use here is going from 5 to 15. That's 3 times bigger, so keeping the same ratio and proportion, this 20 should be 3 times bigger, so that makes this 60. If you wanted to, you could also just say this cross product here is going to be 600, so this should also be 600. All right, so we filled in the table, but we didn't really use a proportion yet. Our initial ratio they gave us was 2 squirrels for every 8 birds. I'm going to write that down. And so what if they said we had 15 squirrels? That goes on top. So for the birds here, let's just use X for a moment. Several ways you could do this. I'm just going to use cross products for the sake of time here, but 2 times X is just going to be 2X, and then 8 times 5 is going to be 120. And then if you divide both sides by 2, we can say X would be equal to 60, which means that there would be 60 of these birds, right? So that hopefully makes sense. When it says how many birds would there be if there were 15 squirrels, you can say that we would have a ratio of 15 squirrels to 60 birds. So that'd be the answer to that part of the question. And then finally, we have to state whether this is a ratio or a rate table. We're going to go ahead and say that this is going to be a ratio table just because these units are very similar. We're talking about animals here, so I would think that they're kind of in the same category of units. All right, let's check out number 2. For number 2, at Princeton Middle School, the ratio of number of students without pets to the number of students with pets is 3 to 1. Okay, so if there are 240 students at the school, how many students have pets? That's if there's 240 students at the school. Okay, so if at first glance you look at this ratio of 3 to 1 and you're saying, wait, that doesn't quite make sense here. Look at the labels carefully. This is the total number of students, and this is the number of students with pets. So if you wanted to create another row, you could here and write number of students without pets. And so if you go ahead and take the total students and take away the students with pets, then you would get 6 students without pets. So you can see the ratio of 6 to 2 matches the ratio of 3 to 1 for students without pets to students with pets. Okay. Then what about this blank over here? Well, if you take this 2 and you multiply by 4, you get 8. So if you multiply this 4 by 4, you're going to get 16 here. That hopefully makes sense just because you can see here if you double this 2 to get 4 as well, you can double 8 to get 16. Okay. Now, if there are 16 total students, 4 of them had pets. That means 12 of them would not have pets, right? And you can see here that a 12 to 4 ratio is also this 3 to 1 ratio that we had before. Now, if you wanted to, we can say here that if there are 20 total students, 5 had pets. That means 15 would not have pets. You can see this 15 to 5 ratio matches 3 to 1 as well. Over here, let's see, if we want to get to 40 to what number of students with pets? Well, if you double the 20, you get 40. So if you double this 5, you can come up with 10 here, right? Now, if there are 10 students with pets here, there would be 30 students without pets, just because 10 plus 30 does equal 40. And again, this 30 to 10 ratio is 3 to 1. And finally, for this blank down here, we can say maybe 5 times 3 is 15, so 20 times 3 gets you 60. So we can say that this would be 60. There would be 45 students without pets here, which makes sense because 15 plus 45 is 60. And you can see 45 to 15 does give us this 3 to 1 ratio. Okay, so the question says, what if there's 240 students at the school? Well, we can see these are all the students at the school. So maybe we can create another one that's not in the table here. Maybe we can say, okay, there's going to be 240 students here, and we'd like to figure out how many total students here are going to have pets, right? So if we see here that this 60, we could use 60 actually pretty nicely. We could times this by 4. And so if we times that by 4, we can multiply this by 4 as well. So 15 times 4 would be 60. So if there were 240 total students, 60 of them would have pets, which also means here that 180 of them would not have pets. Okay, so you can draw these lines down if it helps keep things a little bit more organized here. Okay, but sometimes these tables, they kind of give you some good information, but you can also learn to expand them and see and keep track of all your information that you need here. You can also see here, just for good measure, 180 to 60 is also a 3 to 1 ratio here. So to set up this proportion, we knew there was a 3 to 1 ratio of students without pets to students with pets. So if we wanted to figure out how many students have pets, we were to figure out rather that there were 180 students without pets. So then how many of them would have pets here? Well, you could just go ahead and use cross products if you'd like to. So 3 times x is going to be 3x, and then 1 times 180 is just 180. If you divide both sides by 3, say x is equal to 60. And so summarizing this, we can say 240 total students, that ratio here we can say, and if we had 240 total students, 60 of them would have pets. So 60, I'm going to just write with pets. Now in this particular problem, we also want to say, is this a rate or a ratio table? I think in this case, this is going to be another ratio table because we're talking about students in both cases, whether they were with pets or without pets, very similar units of just talking about students. Okay. All right, let's check out a third one. In this one, it says, on a recent road trip, Harlow ended up spending $37.56 to fill up his entire tank of gas that has a capacity or can hold 12 gallons. Harlow needs a total of 78 gallons of gas to reach his destination. How much will it cost? So you can see here that the 12 gallons for $37.56 is right here. I think the easiest thing to do here is to maybe fill in this first box over here. You can see here 12 becoming 1 here. You can just divide that by 12, right? So if you can take this 37.56 and divide that by 12, we should figure out how much 1 gallon is going to cost. So let's do that on the side here. Let's take 37.56. Let's go ahead and divide that by 12. We like how this 12 is a whole number here, so we can just go straight into dividing. 12 times 3 is going to be 36. We already know this is going to be like $3 and something cents, right? Bring down the 5. 12 into 15 goes in once, so it's less than $3.20. That's going to be 12 remainder of 3. And let's bring this 6 down here. 12 into 36 is going to be 3 times. That's 36. And the remainder here is 0. So it looks like 1 gallon of gas here is going to be $3.13. So it's kind of really nice having the price of 1 because now we can figure out the price of any number of gallons a lot easier. All right, so if 1 gallon is $3.13, what if you want to find the price of 7 gallons? We can just multiply that by 7. So we can just multiply this one by 7. So let's take this $3.13. Let's go ahead and multiply that by 7. Then we should get how much it would cost for 7. So that's 21, carry the 2. 7 times 1 is 7, plus 2 is 9. And then 3 times 7 is going to be 21. So we're looking at $21.91, I believe. So let's go ahead and say 7 gallons of gas would be $21.91. Okay, so this next one's a little bit tricky, right? This one, this blank here, because these numbers are a little bit bigger and the multiplication facts aren't not quite as nice. So how are we going to get to this 8451? Well, you can do a number of things here, but which, cross products do you maybe want to use? You could use these cross products, but that's quite a large number. I think the cross products I'd like to use is going from the 1 to the 8451. You can check this cross product here. 1 times 8451 is just 8451. And that means that this 313 multiplied by this number here should also be 8451, right? So we basically can say, okay, this 8451, if we divide that by 313, we should find out what this empty box is right over here, right? We could probably estimate that it's somewhat around 4 times bigger than here, roughly. So it should be, around maybe 28 or so if we multiply 7 by 4, right? So if we divide decimals, we like our divisor to be a whole number. So let's make both of these 100 times bigger. So let's say this is going to be 8,451 divided by 313. This doesn't go in here, doesn't go in here a whole number of times. I think this is going to be 2. That's 626. If you subtract here, this would be 15 minus 6 is 9. 3 minus 2 would be 1. Then 8 minus 6 would be 2. You can bring down this 1 over here, and then let's see. You can actually see earlier that 7 went into this 2191 3.13 times. So we can actually see that this number has to be a 7 actually, right? So 7 times 313 would be this 2191. So that's kind of nice, right? Just because we knew 7 times 313 or 3.13 would be 21.91. So just moving those decimals over there. So we can say that this would be 27, right? So if Harlow had 27 gallons of gas, it would cost $84.51. All right, for this last box here, we need to figure out the cost of 43 gallons. None of these numbers go into 43 really nicely. However, 1 goes into every number pretty nicely, right? So we could just multiply by 43. So take this 313 here and multiply that by 43. So just a quick multiplication problem. We can go and take 313, that's the price of 1 gallon, and just multiply that by 43 here, so that we would get the price of 43 gallons. So that'd be a 9, a 3, and a 9. Put a placeholder, that'd be a 2, a 1, that's a 5, that's a 1, and a 2. So altogether here, we're looking at 9, 5, 4, 3, 1. We need 2 decimal places. So I think this right here would be $134.59. And so we didn't really set up a proportion yet. We kind of just did a bunch of different calculations. We did know, I think a good proportion to solve here is 1 gallon of gas was 313. So I'm going to say it costs 313 for 1 gallon. So they asked the question of what if there were 43 gallons and you had to solve for that, right? So that would be a good proportion to set up here. This one's nice and easy because if you set it up with the 1, you can say 1 times x is just going to be 1x or just x. We actually already did this multiplication, 43 times 313. So as long as you set up the proportion to show it, you're good to go. So it'd be 134.59. And so summarizing this, we can say if Harlow needed 78 gallons, this would be requiring $134.59. That would be the ratio here, or the rate. Now, one of our units is money and the other one is gas. So I think it's safe to say that these units are pretty different here. So this would be a rate table, right? You'd be at a rate of cost of gasoline. So these different types of units, say this here is a rate table. All right, cool. Let's try a few different problems here. Now you're not going to be given tables, but we're going to be going ahead and practicing making tables to go ahead and solve these problems. Not really using proportions specifically, just making tables to go ahead and figure these questions out. All right, so for question 4, scientists are going to be studying ways to increase the population of wild salmon. For every 8,000 salmon eggs, only 2 adults may survive. How many salmon eggs may be needed to produce 18 adult salmon? So let's go ahead and set up a table here. We could maybe label one as just going to be total for the total number of salmon eggs. And then maybe our other one we can just label real quick as the ones that survive, just to make it as clear and as concise as possible. So we know that if there are 8,000 of these eggs, that we know that 2 of them are likely to survive. So what if we're looking for 18 of them to go ahead and hopefully survive? Well, you can go ahead and, scale up however you'd like to, whatever's easy. So you can say if you multiply this by, 9 for this one might be pretty easy. So if you multiply 2 by 9, you get 18. And so if you multiply 8,000 by 9, you're just going to get 72,000. So this one's pretty straightforward. I don't think you need to do too much just because 2 goes into 18 pretty nicely. But you can see here that that would mean we can go ahead and say that 72,000 eggs are needed to produce 18 adult salmon. All right, let's check out another one. For number 5, an animal shelter can hold a total of 60 cats and dogs. For every 5 cats the shelter can house, there is room for 7 dogs. How many cats and dogs are at the shelter when it is completely full? Okay, so let's go ahead and set up a table. We have a couple animals here. We have cats. I'm going to make a row for cats here. We have dogs. Make a row for dogs. But it does say it can house a total of 60. So I think we're going to benefit from having another column here for the total. Okay, so we know that we can have 5 cats for every 7 dogs. But that's a total of 12 animals, right? We're looking for specifically a total of 60 animals. So I think it's good to kind of set up 3 rows here. And so what if we wanted to say that we wanted to have more animals in this shelter? So you could say something like, what if you wanted 24 total animals? Well, that means you could double the capacity for each of these other ones. So a 10-to-14 ratio still matches, but we're trying to get to 60, right? So you can keep kind of scaling up by whatever number you want here. But I think you could actually also just jump straight to 60 if you can see here that 12 times 5 does get you 60. So if you do 7 times 5, that would be 35 of these would be dogs. And if you do 5 times 5, you would say that 25 of these would be cats. And you can see here that 25 plus 35 does equal the 60 here. So if it's completely full, that means the capacity is 60. You would have 25 cats and 35 dogs. That's how many animals, or cats and dogs rather, that this animal shelter can house when they're at capacity of 60 total animals. Okay, let's check out number 6. At a small music concert, each child in attendance will get a free toy trumpet. 5 adults are expected for every 2 children. Find how many children are expected if there are 15 adults. What about 25 adults? And what about 40 adults? So 3 different questions here. So let's see, we have adults and we have children. I guess I can write child, but you get the idea here, hopefully. So it says the ratio is 5 adults for every 2 children. The question, there's 3 questions they're asking here. So what if there's 15 adults? So if we put 15 adults here, we can say 5 times 3 is 15. So 2 times 3 gets us 6 children. So that kind of answers that question. But then they specifically ask us about 25 adults. So let's see here. We can say 5 times 5 is 25. So 2 times 5 would be 10. So that would be this blank right over here. And then they ask us one final question about what if there's 40 adults here. You can do a couple of things here, but a cool thing you can do with these ratio tables as well is if you add these two, 15 plus 25, that does get us 40, you can add 6 plus 10, which is equal to 16. So that's kind of a nice thing you can do. You can actually add ratios that are equivalent to get new ratios that are equivalent. Or if you said you want to just do 5 times 8 is 40, 2 times 8 is 16. So you can see that also still works. You can also always check cross products. That would be 30 and 30. This is 150. This is 150. This is 400 and 400. This would be 80. This would also be 80. So there's lots of different ways you could do cross products. So summarizing this, if there were 15 adults, we could expect how many? We could expect 6 children? I guess I'll write it out, but children is such a long word to write out. What if there were 25 adults? If there were 25 adults, we would expect from our table 10 children. And then what if there were 40 adults? If we say 40 adults, our table we found out tells us that we have 16 children. And this keeps the correct ratio that we were expected to have here of 5:2 each time. Okay, so let's try one more problem. For number 7, Christian and Michael are training for track season. Christian did 39 sit-ups in 30 seconds. Michael did 59 sit-ups in 50 seconds. Who will likely do more sit-ups in 2.5 minutes? Okay, so this one, I'm going to set up 2 different tables, I think. Let's do Christian over here. And let's do time. So how many Christian does versus time. And then I think it would be good to do one with Michael and look at that and compare it to the time as well, right? So let's see. You could make this one big table if you want to, kind of up to you how you want to do it, but I'm going to do it this way. And I'm going to line these up to keep it as organized as possible. So what do we know initially? We know Christian did 39 sit-ups in 30 seconds. So 39, and that's in 30 seconds. And for Michael, what do we know? Michael did 59 in 50 seconds. So he did more, but he also had some more time, right? Let's go ahead and kind of make another column here. And let's see, we need to compare them at 2.5 minutes. Right now, they don't have the same amount of time here. So let's see if we can get to 2.5 minutes here. If we want to get to 1 minute, that's 60 seconds for Christian. So if you double 39, that's going to be 78, okay? But what if you want to get to 2 minutes? Well, 2 minutes would be what? 2 minutes would be 120 seconds. And so if we double 60 seconds to 120 seconds, you would double 78. If you take that 78 and you multiply that by 2, that's going to be 156 crunches in 2 minutes. All right. But what is 2.5 minutes? Well, 2.5 minutes, I believe, is going to be what? 150 seconds here, right? So you can see here, if you'd like to add 30 seconds plus 120 seconds, that's 150 seconds, which is 2.5 minutes. You can take this 39 and 156. If you add 156 plus 39, you're going to end up with 195. Right? So again, this 2.5 minutes here, you can go ahead and convert that on the side. But again, 1 minute is 60 seconds. So 2.5 minutes is going to be 150 seconds. So that's kind of the number that we're looking for here. Now, what about for Michael? For Michael, if we go to 100 seconds, if you just double 50 to 100, that's going to be 118 sit-ups here for Michael. And then if we go ahead and we're going to try to get to 150 seconds, because that's 2.5 minutes. Again, you could either also, I guess, multiply this by 3 if you wanted to in the beginning. Or we can say 50 plus 100 is 150. So what's 59 plus 118? So if you take the 59 and you add 118, that's going to be 177. Okay, so both of these athletes are very fit here. That's quite a bit of sit-ups for both of them. So the great comparison here that you're looking for is what they did in this 2.5 minutes. So, but if you were to do the comparison here, you can see that Christian's ratio is going to be greater than Michael's. 195 to 150 is a greater ratio than 175 to 150. So that means that he was able to do more sit-ups, or he was more likely to do more sit-ups in this amount of time based on the ratios that we were given. So we can go ahead and say that using equivalent ratios, and a rate table, we wrote rates per 150 seconds, aka 2.5 minutes. In that time, Christian is expected to do 18 more sit-ups. Now, is this 100% true? Maybe not. Maybe Michael would have more endurance over the long run, and that's something you could say as well. Maybe Christian was able to just do, at that rate, he was able to do quite a bit in 30 seconds, but maybe Michael has more endurance. So this isn't like a guaranteed answer here. You could say a couple different things or other variables that may impact these two different athletes. They may just train very differently. Michael maybe trains for endurance and can do a lot of sit-ups over time and doesn't get as tired. But if you're using some mathematical reasoning here, I think there's a few different ways you could go about it. I think if you're using these equivalent ratios and rates and proportions, mathematically, we'd kind of predict that Christian could do more in that time. However, you can also mention different aspects of people getting tired or fatiguing over time as well. You could also say something along the lines of 195 to 150 is going to be a greater ratio than 177 to 150. All right, so there you have 7 different practice problems that helps us apply our understanding of ratios and rates and proportions and kind of just visualize organizing all the information into these tables to help keep things nice and tidy and kind of see how everything's laid out. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.